Sonic lovers, welcome to the channel Gone. Today I will show you how to configure VXLAN EVPN with BGP Unnumbered. As we can see here, this is BGP Unnumbered, so no IP address has been assigned between these interfaces of switches. For this, IPv6 link local address will be used for pairing. Here, this is the required topology that I am using in this video. Now I will go into such switch S1. Before entering into switch S1, as we know in Sonic, by default all ports have assigned default IP addresses. So before starting of the video, I have removed all those default IP addresses. Now I will go into switch S1. Here, as we can see, by using command show IP interfaces, all ports have assigned default IP addresses. Now I have removed these IP addresses by using these commands. Again, I will check the status of IP interfaces by using command show IP interfaces. As we can see here, Ethernet 0 and 4 are not present. So now I will go into topology. Here, as we can see, VLAN 10 is written. Now I will create VLAN 10. Sudo config VLAN add 10. Now I will check the status of VLAN table by using command show VLAN brief. As we can see here, VLAN 10 has been created. Now I will make this port a part of VLAN 10. Now I will use command sudo config VLAN member add untagged 10 Ethernet 4. As we can see here in the port mapping, Ethernet 1 means Ethernet 4. That's why I have made this port a part of VLAN 10 and this is an untagged port. Again, I will check the status of VLAN table by using command show VLAN brief. As we can see here, now this port is a part of VLAN 10 and it is untagged. Now, again, I will go into topology. Here we can see loopback interface, which is loopback 10 with IP address 1.1.1 is written. Now, I will create this loopback interface by using command sudo config interface IP add loopback 10 and IP address is 1.1.1.1/32. Now I will check the status of IP interfaces by using command show IP interfaces. Here we can see loopback 10 is present with IP address 1.1.1/32. Now I will go into topology. Here we can see VNI 10 VTAP 1.1.1. Now I will create VXLAN and then I will assign IP addresses to these VTAPs. Now I will use command sudo config VXLAN add VTAP and IP address is 1.1.1. In this command, I am assigning IP address to this VTAP, which is 1.1.1. Now I will use command sudo config VXLAN EVPN NVO add NVO VTAP. NVO is actually a network virtualization overlay. As we know, in VxLAN BGP EVPN, the concept of overlay and underlay is used. So I am creating a relationship between NVO and VTAPs and EVPN. Now I will use command sudo config VXLAN map add VTAP 10 10. In this command, I am creating a mapping between VLAN and VNI. As we can see in the topology, VNI is 10 and VLAN is 10. So through this command, a map has been created between VLAN and VNI. Now I will check the status by using command show VXLAN interface. Here we can see the name of VTAP is VTAP, and this is the source IP address 1.1. Loopback address will be used as a source IP address, and the name of NVO is NVO, and source interface is loopback 10. Actually, this loopback 10 will be used as a source interface. Now I will use command show VXLAN tunnel. As we can see here, name of this tunnel is VTAP, source IP is 1.1.1.1. Now I will use command show VXLAN VLAN VNI map. As we can see here, this is the mapping between VLAN and VNI. So VLAN is VLAN 10 and VNI is also 10. Now I will save configurations by using command sudo config save flag. Now I will go into switch S2 and repeat the same steps. Here I will show you the status of IP interfaces by using command show IP interfaces. As we can see here, Ethernet 4 and 0 are not present because before starting of the video, the default IP addresses have been removed. Now I will create VLAN 10 sudo config VLAN add 10. Now I will check the status of VLAN table by using command show VLAN brief. As we can see here, VLAN 10 has been created. Now I will make Ethernet 4 a part of this VLAN. Ethernet 4 a part of this VLAN. Sudo config VLAN member add untag 10 Ethernet 4. Again, I will check the status of VLAN table. Here we can see this port is a part of VLAN 10 and it is untagged. Now I will assign IP address to loopback interface, which is loopback 10 2.2.2.2/32. Now I will use command sudo config interface IP add loopback 10 2.2.2/32. Now again I will check the status of IP interfaces by using command show IP interfaces. Here we can see loopback 10 is present and the IP address is 2.2.2/32. Now I will create VXLAN and I will assign IP addresses to VTAPs. Now I will use command sudo config VXLAN add VTAP 2.2.2. Now I will use command sudo config VXLAN EVPN VXLAN EVPN NVO add NVO VTAP. Now I will use command sudo config VXLAN map add VTAP 10 10. As we can see in the topology, the one thing that we should not is that the IP address of VTAP and the IP address of loopback interface is same. So we must assign loopback address to the VTAP. We cannot assign another IP address. So this loopback will use as a source interface, and this IP address 2.2, the IP address of VTAP, will be used as a source IP address. Now I will check the status of VXLAN by using command show VXLAN interface. As we can see here, the name of the VTAP is VTAP, source IP is 2.2.2, and the source interface is loopback. Now I will use command show VXLAN tunnel. As we can see here, the name of the VXLAN tunnel is VTAP and its IP is 2.2.2. Now I will use command show VXLAN VLAN VNI map. Here we can see the mapping between VLAN and VNI is VLAN 10 with 10. Now I will save configurations by using command sudo config save flag1. Now I will go into switch S1. Now as we can see in the topology, the concept of ASN is used. So now we will configure BGP with unnumbered. What does it mean? We will use IPv6 link local address for BGP pairing, and no IP address will be used. Now I will go into Vitaish configuration mode. I will use command router BGP 65000. As we can see here, BGP is already running with AS 65100, which is a default AS which is running in the Sonic. Now I will remove this no router BGP 65100. Now again I will use command router BGP 65000. Now I will use command BGP router ID 1.1.1. Oops, 1. Yes. Now I will use command neighbor Ethernet 0 interface remote 65000 neighbor Ethernet 0 interface remote AS internal. As we can see here we can use two words, internal and external. As we can see here in the topology, both switches are using same AS, which is 65000. So it is IBGP. If these ASNs have different values, then we will use uh, we will call it an EBGP. So IBGP and EBGP. Here it is IBGP, and for IBGP we are using the word internal. Now I will go into address family IPv4. Here what I will do, I will advertise this network 1.1.1/32 by using command network 1.1.1/32. Now I will exit this session. Now I will advertise these VNIs by using L2 VPN EVPN family. I will use command address family L2 VPN EVPN neighbor Ethernet 0 activate, and then I will use command advertise all VNI. Now I will end this session. I will save configuration by using command write. Here we can see all the configurations are saved in /etc/frr/bgpd.conf file. Now I will repeat the same steps on S2. Now I will go into S2. Here I will go into Vitaish configuration mode, no router BGP 65100. router BGP 65000, BGP router ID 2.2.2, and then neighbor Ethernet 0. Oops. Neighbor Ethernet 0 interface remote 65000, then neighbor Ethernet 0 Ethernet 0 interface remote AS internal. Now I will use address family IPv4 network 2.2.2/32. Now I will exit this session. Now I will go into address family L2 VPN EVPN. Here I will use command neighbor Ethernet 0 activate advertise all VNI. Now I will end this session and I will save the configuration by using command write. Now I will go into switch S2 S1 again. I will go into topology. Now I will assign IP address to these PCs, and then I will check the status of BGP unnumbered, BGP neighbors, BGP summary, and all the stuff like that. Now I will assign IP address to this PC by using command IP 192.168.10.2/24, and get and the subnet mask is 255.255.255.0. Actually, this is not a gateway. This is a subnet mask because we are not using any gateway. So first of all, I will remove this and I will write subnet mask. Here I will also write subnet mask because we are not using any gateway here. So I will check the status of IP by using command show IP. So IP address has been assigned. Now I will go into PC2. Here I will also assign IP 192.168.10.3/24, subnet mask 255.255.255.0. Now I will generate a ping request. Ping 192.168.10.2. Yes, it's working. Now I will go into switch S1 and check the status of VXLAN, VNI, EVPN, and all the stuff like that. Now I will exit here. I will use command show VXLAN remote VTAP. Here we can see source IP is 1.1.1.1 and the destination IP is 2.2.2.2 and the creation source is EVPN. So it is working fine. VXLAN BGP EVPN with a number is working fine. But as we can see here, it is showing operational status down. Actually, it is a bug in Sonic. On the front end, like on this screen, it is showing operationally down, but actually it is up. As we can see, it is receiving a response from PC1, so that's why it is actually operationally up. This is actually a bug. On the front end, it is showing operationally down, but actually it is operationally up. Now I will use command show VXLAN tunnel. Yeah, good. Now I will go into Vitish Here I will check the status of EVPN VNI by using command show EVPN VNI detail. Here we can see VNI is 10, type L2. VXLAN interface is actually a VTAP 10 that we have created. SVI interface is VLAN 10. Local VTAP is 1.1.1 because we are present on switch S1. And the remote VTAP that it has learned, which is 2.2.2, because actually in VXLAN BGP EVPN we have to learn the remote VTAP, which is a 2.2.2. Now I will use command show BGP summary. Here we can see L2 VPN EVPN summary. It is showing the neighbor. It is showing total number of neighbors are 1. So everything is fine. Now I will use command show IP route. As we can see here, 2.2.2.2, which was IP address of loopback interface. Now S1 has learned this IP address through BGP, as it is showing B. This is a BGP route. So S1 has learned this route through BGP by using VxLAN BGP EVPN. Now I will use command show BGP neighbor. So here we can see remote router ID, which is actually a S2, is 2.2.2. Local router ID is 1.1.1. And then the most important thing is that BGP neighbor on Ethernet 0. Here we can see IPv6 link local address is used for BGP neighborship. No IPv4 address is used, and no IPv6 global address is used. IPv6 link local address is used for BGP pairing. As here we can see remote AS is 65,000, local AS is also 65,000, and BGP state is established. Here we can see for address family L2 VPN EVPN that we are using. And here we can see next hop is 1.1.1, next hop global, next hop local. Everything is working fine. Now I will go into switch S2. Here, first of all, I will check show EVPN VNI detail. Here we can see VNI is 10, type is L2, VXLAN interface is VTAP 10. Here the local VTAP is 2.2.2.2, and the remote VTAP for this VNI that it has learned through VXLAN BGP EVPN is 1.1.1, which is a remote VTAP. Now I will check the status of BGP by using command show BGP summary. So everything is fine. Now I will use command show BGP neighbors. Here we can see it is established. BGP neighbor on Ethernet 0, IPv6 link local address is used. Remote router ID is 1.1 and the local router ID is 2.2.2. Now I will exit out. I will use command show VXLAN remote VTAP. Here we can see source IP is 2.2.2, destination IP is 1.1.1. Actually S2 has learned the destination IP, and the creation source is EVPN, and it is showing operational status down, which is actually a bug on front end, but actually it is operationally up. Now I will go into topology. Here I will go into PC1 and I will generate a ping request from here. Ping 192.168.10.3. Here we can see it is receiving a response from PC2. So everything is working fine. Every VXLAN interface is working fine. So VXLAN EVPN with BGP Unnumbered has been successfully configured. So thank you guys for watching my video. If you want more videos like this, do subscribe my channel.